Understanding algorithm complexity.
Algorithm complexity measures how resources like time or memory grow as a problem gets bigger. There are three main ways to describe this: worst case, best case, and average case complexity. Understanding these helps predict how an algorithm performs in different situations, guiding better software choices and design.
Worst case complexity explained.
Worst case complexity gives the maximum amount of resources an algorithm might need. For example, searching a value in an unsorted list with linear search. In the worst case, you check every item, so the complexity is O(n). This helps developers ensure their programs won't slow down unexpectedly.
Best case complexity, made simple.
Best case complexity describes the minimal effort required by an algorithm. Using linear search again, if the item you want is first in the list, you only check once, so best case is O(1). While best case performance can be appealing, it's not always representative of what usually happens.
What is average case complexity?
Average case complexity looks at resource use across many typical situations. It calculates the expected time or memory used for random inputs. For example, the average case for linear search is O(n), since the item could be anywhere. This measure gives a more realistic sense of performance for real-world data.
Why these complexity types matter?
Choosing the right algorithm means balancing its performance in the worst, best, and average scenarios. Relying only on best case can lead to surprises, while worst case ensures reliability. Average case guides practical expectations. Together, these measures help make smart, informed decisions when developing software.